All right, so this set of notes, like I said, moisture, clouds, precipitation. Do a little skim over some of these. Okay, so this first one, just vocabulary word, precipitation. Any form of water that falls from a cloud. So it's going to be the standard rain, snow, sleet, freezing rain, that sort of thing. Hail is kind of a different one. While it is a form of water that falls from a cloud, the way it forms is completely different. So it's kind of an oddball. We'll talk about it a little bit later, but it's kind of a weird one. Right, the first few slides here are about changes in state, and not like Indiana to Ohio or something, but a state of matter, or maybe for some of a state of confusion. I don't know. You just never know. First one, evaporation. So going from liquid to a gas. In this example, I put up a picture of the shower head. You can see this kind of white stuff and kind of orangish, reddish kind of stuff. It's called scale. All it is minerals that are dissolved in the water. And when that water evaporates, when it goes from liquid water to water vapor, it leaves those minerals behind. So anytime water evaporates, if there's anything in it, it leaves that behind. It doesn't take it with it. So if you set out a glass of salt water, all that salt is going to be left in the glass, whereas the water will evaporate. And fun fact, if you want to clean that without unscrewing the thing and all that stuff, you just take like a Ziploc bag or something and put vinegar in it, and then put the shower head in the bag, and then like tie it around it and just let it soak for a couple hours. And the vinegar will dissolve all that scale and all those minerals. Be good as new. So evaporation going from liquid to a gas. The opposite side of that one is condensation, going from a gas to a liquid. So a couple of examples here. Some sort of cold drink, and on the outside, water condenses on the outside, or mirror. After a hot shower or something where water condenses on the mirror. Again, this is water vapor that's condensing back into a liquid. We'll talk a little bit about this one here in a little bit too. This next one, not real common, but it's kind of cool, especially not really common in just kind of the natural world. Sublimation, so going from a solid to a gas directly, no liquid phase. So if I had a piece of ice that's just frozen water, I set it on the table, it's going to melt, there's going to be a puddle of water, then the puddle of water will evaporate over time. Sublimation is just, if I were to put the piece of ice on the table and then it just turns into gas. Like I said, not a common thing. Water definitely doesn't do that. But something that does do that is dry ice, which is why it's called dry ice. Dry ice is made out of frozen carbon dioxide. And when it starts to warm up, it goes directly to a gas. There's never a liquid phase where there's a puddle of CO2 there. It just goes directly from solid to gas. Can't remember the exact temperature. I think it's negative 163 or something like that. It's real cold stuff. If you hold it in your hand, it'll burn your hand, it'll freeze to your hand. It can be pretty nasty stuff like that, but it's pretty cool. And it's really good at keeping stuff really cold if that's what you need. Now, kind of the opposite of sublimation, going from a solid to a gas, is deposition, going from a gas to a solid. So this example, this person obviously is not maintaining their freezer very well. It's a very cold surface, and water vapor that's in the air, when it comes into contact with that surface, goes directly from gas as water vapor into ice, or it freezes as soon as it touches it. There's never that liquid state and then it freezes. So yeah, this is not a good thing. You need to take care of that. So in this chart, this just shows all those processes. The names of them. We're not really worried about the energy, absorbed or released or anything like that. But going from solid to a liquid is melting, liquid to a gas evaporation, and sublimation. Gas to liquid condensation, liquid to a solid freezing, that sort of thing. Like I said, we're not worried about the energy. Although this does show why when you're wet, like you get out of a pool or shower or whatever, you're colder when you're wet because that water is pulling heat from your body. Because that water's trying to evaporate, so it's pulling heat from anywhere it can. And it's pulling heat from your body. So that's why you feel cold when you're wet. Fun fact for the day. That and the shower head thing, I guess. Another vocabulary word, humidity. This is one I'm guessing most of us have probably heard this one before. Just the amount of water vapor in the air, the moisture in the air. Humidity can change, from hour to hour depending on what's going on with weather. Certainly season to season. During the winter, when it gets cold, the humidity tends to be really low. It's very dry. So you notice that your skin might dry out more quickly. You might get nosebleeds because your sinuses dry out and can crack. Whereas in the summer, that's not an issue because it's there's much more moisture in the air. It's hot. It's humid. There's a lot of water vapor in the atmosphere. And saturated, just like if anything is saturated, it just can't hold anymore. So if a sponge is saturated with water, water's just dripping out of it. It can't hold it. The atmosphere is the same way. If it's saturated with water vapor, it can't take any more water vapor. So things aren't going to evaporate quickly. And then typically that's going to lead to precipitation of some form or another. All right, this one, dew point. I think one of the more confusing things about dew point is because it changes. It's not just a set number. And the dew point is just that temperature where if the air is cooled below that temperature, then it becomes saturated and then water condenses out of it. That water vapor condenses into liquid. So if there's a lot of humidity, the dew point is higher. If it's really cold or really dry, the dew point is really low because there's not much humidity there. But this is why some mornings, if it's a little colder than normal, you might have dew form on the grass and all that stuff like that, but it's not something that happens every day. And then when we talk about condensation for a second, the examples of the glass with the condensation on the outside or the mirror in the bathroom, after a hot shower kind of thing, those surfaces are colder than the dew point. So because the humidity is really high, even just the temperature of whatever house it's in or whatever, that mirror is colder than the dew point, so water condenses on it. All right, the next one. This is an important one. Front. So front is just kind of a general term for a boundary between air masses. So with this one, we'll talk about warm and cold. You can also talk about front for differences in pressure systems, like high pressure system and low pressure. But I would star this one. It is an important one. So in this diagram, the top one is a warm front. So that's where warm air is moving in to an area where there's air that's colder than that air, basically. Because we know that warm air rises and cold air sinks. As this warm air moves into that area, it's going to move over the top of the cold air. When it does that, there's now a meeting of warm air that's going to have a lot of moisture in it, or at least more than the cold air. And then you have cold air, and where those two things meet, that cold air comes into contact with that moisture and it forms clouds. Because it's making that water vapor in the warm air condense, forms clouds, and then a lot of times you'll get rain. But when warm fronts are moving in, the type of rain you get is just rain. It's just kind of a rainy, gray, dreary day. It's not, and not typically crazy weather and crazy thunderstorms and that sort of stuff. That kind of crazy weather that comes from cold fronts. And some of these cold fronts are pretty severe changes. Within the matter of minutes, as a front moves in, temperatures can drop 10, 15, 20, 25 degrees very rapidly. Because cold air sinks, as that cold air moves into the area, it's kind of acting like a bulldozer. It's just plowing through, and it's forcing that warm air up into the higher up into the atmosphere, because that warm air has moisture in it, and it's being forced higher up into the atmosphere where it's colder. It doesn't take long for that moisture to condense and form clouds. And these are the types of clouds that form severe weather. And these are the types of clouds where you have, lightning, thunder, high winds, lots of rain, maybe hail, maybe tornadoes. It's with these cold fronts that move in and create a lot of severe storms. So like I said, that's important, especially this time of year, especially here in Indiana, because it's kind of what we have here. A few little tidbits with clouds. Clouds are classified by their form and height. So there are certain terms used for the form or kind of the shape of the cloud, and then there's certain sets of terms used to describe the altitude that they're at. So the way those get pieced together, it's kind of a naming system that they use to name those. So this first one is a cirrus cloud, really high altitude. They're very thin. You can almost see through them. They're very kind of wispy. A lot of them are actually ice crystals. That's one type. Just 1 second. The next type is cumulus. This is kind of I don't know. For me personally, this is kind of the stereotypical cloud. Just kind of a little fluffy kind of cloud. It's not usually associated with any specific type of weather or anything like that. Next one is a stratus. Stratus cloud. We've actually seen a variation of that word when we talked about sedimentary rocks. We talked about a rock could be stratified, so it kind of has the property of layers. Or if you're talking about one specific layer, that would just be strata. But this is just a cloudy day with stratus clouds, just kind of a blanket of clouds. Might rain, but typically not. It's just kind of, you can't really see blue sky. It's just a gray, cloudy day. Related to that, it's a nimbostratus cloud. So these are big precipitation forming clouds. And when it's warmer out, it's going to have rain. When it's colder, it's going to have snow. But again, with rain, it's not huge thunderstorms or anything like that. It's just kind of a rainy day. And this diagram shows a bunch of different types of clouds. And we're not going to get into a bunch of different specifics or specific types or anything like that. The one that's most noteworthy is this one on the right, the circled cumulonimbus cloud. So these are the ones that these cold fronts form. And if you notice how much larger they are compared to other clouds, they're very tall. They have a lot of height to them. And again, that's because as that cold air is moving into an area, it's forcing that warm air up, and it's forming these really tall clouds. This is the anvil head. Sometimes we're referred to as anvil heads or even thunderheads because they do result in thunderstorms, lightning, thunder, lots of rain, high winds, maybe hail, maybe tornadoes, all that stuff. Fog. It's just a cloud at ground level. Typically think of that as what it is, but that's what it is. A couple different modes of formation. You can have evaporation from some sort of a body of water, or by just cooling to where it cools the moisture in the air, and then that condenses into a cloud. This diagram, as far as different types of precipitation and what actually reaches the surface, it just depends on kind of the last type of air that it goes through. And so if it's warm the whole way, you're gonna have rain. If it's cold the whole way, snow. And you kind of have some variations in there depending on how much cold air it's going through, whether you have freezing rain or sleet. So there's that. And then hail. I mentioned it. I actually need to check this to see if it's still accurate as far as being the largest recorded hailstone. But this one being 7.9 inches or 20 centimeters in diameter, almost 2 pounds. So I mean, it'd probably be about like a volleyball of solid ice falling at over 100 miles an hour from the sky. That could cause some problems. Now, if you look at this has been cut in half. Now, if you look at it, you'll see these rings. So the reason it's like that is the way hail forms is in those really tall cumulonimbus clouds. As you go up higher and higher in altitude, it gets colder. So at some point, there's a line where above it, it's below freezing. And then below that line, the temperature is above freezing. So these rain droplets are pushed upwards and they freeze. They form a little ball of ice, which is kind of the nucleus, which is kind of a center point. And then that little piece of ice can fall and when it falls below that freezing line, then more water can stick to it, liquid water, and then it can be blown back above the freezing line and it freezes. And then this process just goes over and over again. So then you have layer on layer on layer on layer on layer. And that process can keep going until it gets to the point where it's too big for the wind to keep it, suspended in the air. So like, this big one that was almost 2 pounds, the amount of wind to keep a piece of ice, like I said, probably about like a volleyball, suspended in the air just by wind pushing up that's a big storm. So hail's not the most common thing, but it does happen. And when it happens, that usually means that the conditions are right for pretty extreme weather and potentially tornadoes. So it's definitely something that you should pay attention to whenever you see it, and just kind of be a little more aware of your surroundings when that happens.